All right, I attached this worksheet just this morning, forgot to attach it to the original. So if you haven't gotten it, I'll send it out again just to make sure. This is systems of equations. I'm going to go over this a little bit. I'm going to do numbers 1 and 8 on this worksheet to give you an idea of how to do systems by graphing. Like I wrote, this is the most basic way of doing systems. It is also the least efficient way of doing systems when it comes down to really getting better problems. All of these on this worksheet all work out nice and neat. But you will get systems where some of the answers are fractional answers. You can't find fractional answers really very correctly by the graphing method. We will do the elimination and the substitution method, probably substitution and elimination methods as we go, probably end of today as like something to look over the weekend, and then put more time and effort into it on Monday. But no homework over the weekend, maybe just stuff to look at, nothing to do. But I'll go over any problems with graphing and equations that you need to go over. You need to be solid with those things. And this is going to solidify your graphing abilities, because you've got to set things up into slope-intercept form. Y equals mx plus b. Like number 1, they're already written in y equals mx plus b. So this is easy to graph. The first one I'm going to put in purple. 2/3 x minus 1. That means I cross the y-axis at -1. So I put my first dot there. And my slope is a positive 2/3. Up to right 3. Up to right 3. So up to right 3. Up to right 3. Up to right 3. Now, you don't need to go as far as I just did. You can do like 1 or 2 this way. But if you get good at this, down 2, back 3. Down 2, back 3. Down 2, back 3. It takes you no time at all to graph these equations when you get good at knowing that it's just, here's where it crosses the y-axis. This is how it moves. Okay? Now, the second one doesn't have a fractional value for the slope. It's a -1. You can just turn it into a fraction by going like that, putting it over 1. And we're going to make this one in red. This one crosses the y-axis at a positive 4. So right there is my starting point. And my slope is a -1. That means it's going down. If you get a graph that's going up with a negative slope, you know you screwed up. So you got to go back and go, wait a sec, what did I do wrong? But my slope is -1. That means down 1, right 1, down 1, right 1. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right, down right, down right, down right, okay? Or up, back, up, back, up, back, up, back. I've got a billion points that I've just plotted right here. I circled this one because this is where the 2 points intersect at 3, 1. So our solution to these equations, the solution to the system of 2 equations, is 3, 1. What does that mean? That is the one point that can be placed into both equations and be a solution for both of those equations. They've got tons of solutions, an infinite amount of solutions, but there's only one in this case that would work for both. So if I put a 3 in for this one, the 3 and the 2 cancel out. 2 minus 1 is 1. It worked. If I put a 3 in here, 3 times -1 is -3. -3 into positive 4, make positive 1. It works for both. That is the only point that will work for both of these equations. Now, there are different answers. Now, like we said before, if you have the same slope for 2 different equations, that means they're parallel. That means there's going to be no solution for those 2 equations. Now, if they're the exact same equation, then you're going to have an infinite amount of solutions. That'll come in handy with the later stuff that we do on the worksheet that I'll probably give you, or quiz that I'll give you on Monday over systems. There's questions on it that say, okay, will it have one solution, many solutions, infinite solutions? Now, this is the last one, number 8. This is what they do to mess you up with these problems. They didn't put it into slope-intercept form, so you've got to convert it and put it into slope-intercept form. Really pretty simple. You just bring the 100 over the other side. So it's 30x plus 50y is equal to 100. Then subtract the 30x, and it turns into 50y is equal to negative 30x plus 100. Then divide everything by 50. And you're going to go, oh, some of you, oh gosh, wait a sec, 30 is not divisible by 50. Guess what? It's the negative 3/5. The zeros cancel each other out. Now this one's nice. 100 divided by 50 is just 2. So the equation up here is y is equal to negative 3/5 x plus 2. Okay, that's sloppy. I'll write it over here. Y is equal to negative 3/5 x plus 2. Okay, the next one is basically the same thing. Now, some of you are going to look at this and go, well, in this last one, I could have divided everything by 10 and made it 3x plus 5y is equal to 10, or minus 10. Yes, you could do the same thing here. Divide everything by 3. 3x divided by 3 is just 1x, or just x. Negative 15 is a negative 5y. A negative 30 is a negative 10 is equal to 0. Now it's just basic single-digit numbers. Plus 10. Bring the x over. And it should be negative 5y is equal to negative 1x plus 10. Okay? So far, so good. Divide by a negative 5. Y is equal to, negative divided by a negative is positive, 1/5 x. Positive divided by a negative is negative 2. Okay? Now, you've got two equations. Y is equal to 1/5 x minus 2. Y is equal to negative 3/5 x plus 2. Let's graph them. Let's graph this one first. Crosses the y-axis at 2. And it's got a negative 3/5 slope. Down 3, right 5. Down 3, right 5. Or up 3, back 5. Up 3, back 5. I've got those points for this first one. Let's do the second one. Now, if you've got different colored markers or pens, it makes it nice and neat, especially when we start getting into systems of inequalities. You're going to need to see different shades of stuff. This one crosses the y-axis at negative 2. This is negative 2 right here. And it goes up 1, right 5. Up 1, right 5. I'm done. I don't need to go any further if all I'm looking for is where they intersect, okay? I don't need to go down 1, back 5, down 1, back 5, up 1, right 5, and create the line. It's nice. It shows that you understand what you're doing. But once you find the intersection of these 2 points, you're done. You need to find the ordered pair. Right 5, down 1. 5, negative 1 should be the ordered pair that if I put it into both of these, it'll work. If I put a 5 here, the 5's cancel out. 1 minus 2 is equal to negative 1. Yes. If I put a 5 in here, it's negative 3, and negative 3 and a positive 2, negative 1. Good. 5, negative 1 is the correct answer. All right. Those are the systems problems. You can practice those graphing ones on your own. Plot the points, see where they intersect each other. Like I showed you here, it should get pretty quick with what you're doing and be not so horrible after a while. But again, the graphing method for this is the one that is going to take a long time to get get the answers for them. When you start to really grasp the substitution and the elimination method, these methods this method that I'm showing you right now, you'll never, ever, ever use it once you learn those other methods. This is going to seem like the easiest thing in the world until you see the other ones and really take time and understand them. So don't worry, don't freak out. I'm sending this video right now and you can use it on systems. If you need help on any of the other stuff for the equations, the point slope, slope-intercept, finding slope and using it to create a line, let me know. You need to know those things and I can go over them. So I will talk to you later. Bye.